A common misconception is that water spirals down a drain due to the Coriolis force, which is the effect of Earth's rotation on moving objects. While the Coriolis effect does influence large-scale phenomena like weather systems and ocean currents, it is not responsible for the spiraling motion of water in sinks, bathtubs, and toilets. In reality, the forces involved in draining water are far too strong for the Coriolis effect to have any noticeable impact. To understand why the Coriolis effect is negligible in draining water, let's look at the relevant formula for the Coriolis force. Fc, the Coriolis force, equals 2 times the mass of the object times the cross product of the velocity of object v and the angular velocity of the rotating system omega. The Earth's angular velocity is very small, and the velocity of water draining in a sink are also relatively low, for example, a few centimeters per second. In contrast, other forces like the water's initial angular momentum and the shape of the basin and the friction with the walls of the sink are far stronger and more dominant. The Coriolis force acting on the water in a drain would be so small that it's nearly impossible to detect. Therefore, the familiar spiral of water down a drain is not caused by the Earth's rotation but rather by these more powerful local forces. Just in case you are not still convinced, let's look at the following example where the velocity of the draining water is 0.1 meters per second. The Coriolis force acting on it would be on the order of 10 to the power of -6 newtons, far too weak to influence the direction of the water flow. As you can see, the Coriolis force is extremely small compared to the gravitational and viscous forces. It is about 1 million times smaller than the gravitational force and about 1,000 times smaller than the viscous force. This is why the Coriolis force has no significant effect on the motion of water draining from a sink. Local forces dominate the process. In summary, the belief that the water spirals down a drain due to the Coriolis force is a misconception. The Coriolis force is too small to affect such a small-scale system where local forces like angular momentum and the basin shape dominate. The Coriolis effect does become significant, however, in large-scale systems like weather patterns or moving vehicles over long distances where the Earth's rotation plays a more substantial role. Thanks for watching.